Hello, today we'll go through a tutorial on Nodit MCP. Nodit MCP provides all the context that an LLM needs to understand and utilize Web3 APIs, enabling faster and smarter development of Web3 services. Shall we get started? What problem does MCP solve? First, LLMs require context to think and respond intelligently. Today, that context is often delivered manually through prompts, a process that's messy, inconsistent, and hard to scale. There's no standard way to provide structured information, and critically, LLMs can't access external data sources by themselves. What does MCP do? MCP defines a standardized way for tools to deliver that necessary context to the model. With MCP, LLMs can use tools to access APIs and external data. They decide when and how to use those tools, making the process efficient and autonomous. This shift enables models to actively build their own context rather than waiting passively for it to be fed. Let's take a closer look at how MCP actually works in practice by walking through its architecture. On the left side of the diagram, we have what's called the MCP host. This is where the language model, like Claude, runs. Each model instance includes a built-in client component, and this client is what communicates with the MCP server. The MCP server plays a central role. It's responsible for handling every request for context, whether that context comes from local files or external services. Essentially, it acts as a dispatcher that finds the right information the model needs at the right time. Now, where does this context come from? The server can look locally, for example, retrieving documents or structured data from a file system. But it's not limited to local sources. It can also reach out to remote services like APIs or databases, pulling in live external data that the model can use in real time. Here's how the overall flow works. When the model needs more information to respond effectively, the client sends a request using the MCP protocol. The server then processes that request, pulls in the relevant context from either local or remote sources, and returns it to the model. This enables the model to reason more accurately, respond more intelligently, and build its own context dynamically. In short, MCP allows models to go beyond static prompts, giving them the tools they need to actively fetch and use relevant data exactly when they need it. Let's now compare how things work with and without MCP, specifically using the Nodit MCP server in a blockchain integrated environment. On the left side of the slide, we see the traditional setup without MCP. Here, the user sends a prompt directly to the LLM, but before that, they often need to manually gather additional context, such as data from blockchain APIs or on-chain contracts. This means writing code, calling APIs, and manually injecting context into the prompt. It's a manual, developer-heavy process, and it doesn't scale well for non-technical users. Now let's look at the right side. The setup with MCP integrated through the Nodit MCP server. In this case, the user still interacts with the LLM through a prompt, but this time, the LLM is enhanced with Nodit's API layer. Instead of manually injecting context, the MCP framework allows the LLM to fetch real-time data from the blockchain automatically via Nodit APIs. This context is seamlessly injected behind the scenes, so the user simply gets a complete, enriched response without writing code or understanding the data sources. Now let's walk through a real-world example that highlights the difference between using MCP and not using it, specifically when analyzing an XRPL transaction. Let's begin with the case without MCP. Imagine a user asks the model, "Can you analyze this XRPL transaction?" The model receives the transaction hash, but since it doesn't have direct access to blockchain data, it tries searching through public explorers like XRP Scan. However, without true integration, it usually ends up giving a vague or incomplete response, like, "I couldn't verify the status of this transaction." It's not very helpful and, frankly, kind of frustrating. The user is left without real answers and often with even more questions. Now let's see what happens with MCP. The same user sends the same request, but this time, the model is powered by the Nodit MCP server. What happens next is transformative. Instead of manually looking things up, the MCP layer automatically queries blockchain APIs, fetches live transaction data, and injects it into the model's context. As a result, the model responds with a complete and accurate transaction overview, but it doesn't stop there. MCP also enables rich visualizations, like detailed token flow diagrams, currency exchanges, and summaries of how the assets moved. You can instantly see things like who sent what to whom, whether currency exchange was involved, which tokens were burned, redistributed, or routed through multiple accounts. Now that we understand what MCP can do, let's go ahead and actually set up the Nodit MCP using Claude as our LLM. First, open up the Settings menu. Under the Developer section, you'll see an option to enable MCP. Click on Edit Config. This is where we'll add the necessary configuration. At this point, don't forget, you'll need to generate an API key from Nodit. This key allows Claude to securely access blockchain data through the Nodit API. Once you've added the API key and saved your config, that's it. Setup is complete. Pretty simple, right? Finally, just restart the model session, and now Claude will be equipped with MCP powered by Nodit. Now that we've restarted the session, let's make sure that MCP has been successfully applied. First, go back into the settings. If the setup went correctly, you should now see Nodit listed in the configuration section. That confirms MCP is active. Next, check the Tools panel. Here as well, you'll notice that Nodit has been added to the list of available tools. That means everything is working as expected. Now that we've set everything up, let's walk through a real use case to see Nodit MCP in action. This time, we will build an app that analyzes a given EVM address when it is entered. Please write a prompt that includes the desired features and requirements. I would like to retrieve the tokens and NFTs owned by the wallet and analyze data related to its transactions and activity history. The process begins by first checking the list of available Nodit APIs. This includes endpoints for things like wallet balances, token transfers, transaction details, and more. Once the system understands what the user is asking for, it immediately uses the function called Nodit API to search for the most relevant API that fits the request, whether that's fetching a transaction record or pulling token transfer history. Once the appropriate API is selected, it executes the call using GET Nodit API and retrieves real-time data directly from the blockchain through Nodit. Now comes the powerful part. MCP then takes this raw data, which includes complex fields like addresses, timestamps, token amounts, contract interactions, and neatly organizes it into structured documentation. You'll see all the critical details clearly laid out. It's formatted in a way that's readable and technically complete. All right, now let's move on to building the actual app based on everything we've explored so far. We've gone through the overall goals, reviewed the necessary APIs, and considered how to structure the data and logic. Now we can put everything, whether it's wallet tracking, transaction analysis, NFT insights, risk scoring, or any other functionality, everything is welcome. As for me, I'll describe how I plan to structure the application in terms of directory layout, file organization, and the separation of back-end and front-end components. Now comes the fun part. You can actually see the files being created automatically, along with all the necessary code being generated in real time. There's no need for you to write a single line of code yourself. Amazing. What used to take hours of boilerplate setup, directory structuring, and initial configuration is now done in seconds. I've fully integrated this workflow with Visual Studio Code, so as soon as I hit Run, it automatically starts generating the full folder structure for the project. You'll see it create directories like API, Services, Components, and Pages, all neatly organized and ready for development. Each file comes pre-filled with scaffolded logic, API handlers are linked to Nodit endpoints, the front-end components are pre-wired with UI elements, logic is embedded right into the structure via MCP configuration. It's not just the structure, Even the content of each file is generated with intelligent defaults. And the best part? All you have to do is sit back, watch it unfold, and maybe make a few tweaks if you'd like. It's fast, flexible, and fully aligned with your intended use case, whether it's a transaction explorer, a wallet dashboard, or an on-chain analytics tool. This is where code meets creativity. And building powerful blockchain-based apps becomes as simple as describing what you want. So let's keep going and see what this app can really do. Now let's run the app we've built. First, navigate to both the backend and front-end folders and install the dependencies. After that, start the backend and front-end servers. Here's the running screen. Looks clean and well built, doesn't it? Let's try entering an address. We can now see the current balance, and it even shows us a risk score. Currently, no tokens are held in the wallet. However, it owns one NFT. Shall we check the transactions as well? There are 4 records available. When you click on a transaction hash, it redirects you to Etherscan, where you can view the actual data. Let's click on the Final Stats tab. You can see some detailed information there. That wraps up today's session. I hope you'll give Nodit MCP a try and create your own amazing Web3 app.